Unit 3 is kind of, it's not going to be anything like what we've done, which could be a good thing, could be we've it different. And so, vocabulary we're going through period. Y value P function. So I'll use it starts over to do f. So from -1 to so do 2 more from 1.2 1 Here's another one. Repeat turns. A periodic function repeating, and you can kind of start and I like to five is how long my period is 5. But basically, you can pick out any 5 if it's long, and that would acting over. So number 1, we're going to actually find is a periodic function, knowing that it repeats. So G of 14. Well, every 5 units, they have their same Y values. So G of 14 is the same as G of 9. Is the same as G of -1. All of those would have the same Y value. So every 5 units, because the period is 5, every 5 units the Y values start repeating. So G of 4 I can find is what? 7. G of negative 1 is 7. So really what we have to do is add or subtract multiples of 5 to see until I get x values that are on my graph. So like, just depending on what graph you have. So G of 72, okay, multiples of 5 are also multiples of 10, right? So I could go down by 10s. So this would be the same as G of 62. Would be the same thing as G of 2. If I kept subtracting multiples of 5 or 10, I would have G of 2 would be one of those. So G of 2 is 6. That should also be the same thing as G of 7. 6. G of 12, G of 17, G of 22, 27, 32, 37, and so on. So G of negative 17, if I keep adding 5 over and over, 5 or 10 or 20 or whatever, any multiple of 5, I would have G of negative 7, G of negative 2, G of 3, so G of negative 2 is 7, G of 3 is 7, so whatever the period is, you add or subtract multiples of that number and your y values are going to be the same. Are there any questions on that? The same thing works when you're given a table. It tells us the graph of H is periodic. It has to tell you that for this to work. You have to know that it's periodic, and it's telling us that the period is 5, just like our previous one. So H of negative 2 is the same thing as H of, if I add or subtract 5, it'll have the same answer. So negative 2 plus 5 is 3. So H of negative 2 is going to give me the same answer as H of 3, which is what? The 3 is the x, so it's 0. 0 is right. The 3 is the x. H of 3 is 0. If it said H inverse of 3, then it would be 4. So H of 6 is the same thing as H of what? 1. Also H of 11, but I don't have an x value of 11, so that doesn't help me. So H of 6 is the same as H of 1, which is what? Negative 2. Number 6 is composition. It says H of 9. So H of 9 is the same as H of 4, which is H of 4 equals 3. And then I have to find H of 3 because my composition, and you get 0. Because it's H of 9. Okay. H of 9 is 3, so then I was doing H of 3. Okay. Composition, you do inside first, then you do the outside. Number 7, it says h of 5k minus 3, where k is an integer. So what if k is 1? That would be h of 2. We don't have h of 2. If k is 2, that would be the same thing as h of 10 minus 3 is 7. What is h of 7? 2. Alright, numbers 8 through 11 looks really confusing because there's lots of pies. Guess what? You're going to see this every day in Unit 3. You're going to see pies like this. This is getting into some trig. So, it tells us that it's periodic, but it doesn't actually tell us the period. So, if I start tracing here at the origin, when will I stop tracing before I repeat again? So I'll go up and then down. And then what's going to happen here? It's going to start repeating. I'm going back up. So the period of this one starts at 0 and goes to 2 pi. So what's my period? 2 pi. So at every 2 pi's, it repeats again. So number 8 says f of pi. Here's pi. That's on the graph. What's the y value there? 0. F of 7 pi is not on my graph, but I know that 7 pi, that's the same thing as 5 pi, because if I have 7 pi, think of it like kind of like x. If I have 7x and I subtract 2x, I have 5x. Same kind of deal. So this would be f of, same thing as f of 3 pi, which still is not on there, which is f of 1 pi. Those are all, because it's periodic, those all have the same y values. And f of 1 pi is 0. We just did that one. Number 10, f of negative 9 pi over 2. If you're adding negative 9 over 2, okay, let me show you in your calculators. Negative 9, I'm going to leave off the pi. Negative 9 over 2 plus 2 is negative 5 over 2. Plus 2 is negative 1 over 2. 1 pi over 2. So I do have negative pi over 2. That's right here. What's that y value? Oh, you can't see it, sorry. Right here. Negative pi over 2. Negative 1 is that. F of negative 8 pi, that's the same thing as f of negative 6 pi, negative 4 pi, negative 2 pi. Oh, I have that one. F of negative 2 pi. Negative 2 pi. What's the y value? 0. Now we're going to look at a question. This is, you're going to see an FRQ that's kind of set up, has a story like this, and I'm guessing you're probably going to see down there at the bottom that little squiggly with the point. So it's going to give you some information. It's probably going to give you some measurements. We're going to draw that on there. So this figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving minute hand. So 8, that's 8 inches right there. The center of the clock is 120 inches directly above the floor. At time, let's make a little, we're going to make a time versus height t-table. So at time, t equals 0, the minute hand is pointed directly up at the 12. So this right here, the way it's pointed right now, time is 0. How high is the top of that minute hand? 128. Good. Now it says the clock is not working properly and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up at the 12 is at time t equals 30. So at 0, it's at 128 inches, and when t equals 30, it's at 128. So this is a periodic function because if we're just comparing the height, like the tip of the minute hand, it's going to start repeating. Like it starts up here at 128, it goes down, and then it's back at 128. It repeats itself. Right, so let's say halfway through there, so at 15 minutes, the minute hand is going to be down here at the 6. Okay, so how high up would it be there? When the minute hand is pointing down. How high is that? The tip of the minute hand from the floor. It's 112. Because here your minute hand is going to be, here. So the 120 goes up to the center. It's going to be 8 less than that. So at 15 minutes, it's going to be at the bottom. Okay, so and then we'll find the halfway mark between those. So when the minute hand is at the 3, what's your t? How many minutes have passed? It's halfway between these two. What's halfway between 0 and 15? No, what between 0 and 15? What's halfway between those two numbers? 7.5. Okay, and then, so if it was here, what would the height of the minute hand be? 120. Okay. What's halfway between 15 and 30? 22.5. And so when the minute hand is over here, how high is it? 120. So you are going to see, and I have several different scenarios that they're all going to have the same kind of repetitious pattern. So when it gets back up here, it's gonna follow the same pattern. It's gonna be 128, 120, 112, 120, 128, 120, 112. It's gonna keep doing that over and over and over again. We're gonna see, I'm gonna pull up some different examples and we'll just try to come up with the table to try to find those points. But based on the mock exams that have been released, you're gonna see a graph like this where we have to put those points in. Once you have found these numbers, you've done the hard part. So notice we have 2 high points, 2 middle, and then the lowest. So the lowest would be the one in the middle. So the 15, 112. So it's going to ask you to write down some coordinates for these. The 15, 112. Your highest ones would be 0, 128, and 30, 128, and then your 2 middle, 7.5, 120, 22.5, 120. So really what you're going to do is you're going to find the 2 highest and then find the middle of those. Center, and then the center again. And we'll look at some more examples when we get time. So part B says refer to the graph of H in part A. The t-coordinate of G is T1. That right there is talking about T1. And the t-coordinate of J is T2. Asking us 2 things about H. It's asking if H, so if this graph is positive or negative, and if it's increasing or decreasing. Are my Y values positive or negative? Positive. When it's asking if a function is positive or negative, it's asking if it is above the x-axis or below. Are your y values positive or are they negative? So from here to here, y values are positive. Is my graph increasing or decreasing? From here to here. Wait, from G to J, yeah. Decreasing. It says, describe how the rate of change is changing. When it's talking about the rate of change, it's asking about the concavity. From G to J, is it concave up or concave down? It's concave up, which means the rate of change is increasing because G is concave up, or H, sorry. The graph is called H. So if it's concave up, your slopes are increasing, they're getting bigger. If it's concave down, your slopes are decreasing. And that's all for that.